Hey guys, I guess this will be the way that I communicate with you for the next 2 weeks, and hopefully only 2 weeks. But what I'm going to try to do is just record a lesson, and then I want to be able to answer questions that you have either with through a Google Hangout or something so that if some of you have questions, then I can answer them. I know sometimes it's hard to answer math problems over an email. So we're going to kind of work with that as we go. But for now, I'm just going to start recording myself, which is not fun at all, but better than me saying figure it out on your own, right? So the first thing I just want to mention is the notes that we took the last week of the quarter on expected value and standard error. I put in Canvas on the calendar page. So if you click on this event right here, then you have those notes right there as a PDF. So those of you that weren't here, you have access to that. And then the class should still be in the Google Drive that I shared with all of you. So that recording should still be there if you want to watch that class so that you know what we missed. Because I wanted to talk about the assignment that we started to work on. It was this Recitation Packet 8. And it was where we talked about setting up a box model that represents the problem, and then from there finding the EV sum and SE sum. And then we use that to figure out the chance of something happening. So let's see, I think looking at my notes here, I think we talked about 1 and 2 in class. So I'm going to skip to number 3. And then if you weren't here and you need help on number 1 or 2, just let me know. And I'll help you any way that I can. So number 3, you play a game in which you roll a die. If it lands on 1 or 6, you win $1. If not, you lose $1. And we're going to play this 400 times. So the first part A, is wanting to know how much money we expect to win. So this box model is going to be different than part C, which is how many times do we expect to win? Because if you think about how much money you win, that will have a different value on the tickets than how many times you expect to win, because that's just going to count whether you win or lose, right? So this one with how much money, and I may have helped you set up this one too. Did I? Guess I should check. I think I just helped you set it up. I don't know. If not, it will be a review, but okay. So if you think of when you roll a die, if you roll a 1 or 6, you win $1. So there's 6 sides on the die, which means there's going to be 6 tickets in our box. And 2 of them, the 1 and 6, is where we're going to win $1. So I'm going to put those 2. I'm going to win 1. And then the other 4 sides of the die, right, is where we're going to lose $1. And so that would be the box model. And then we're going to do that 400 times, right? Because we're going to play that 400 times. So how much do we expect them to win? So that's obviously you're going to find the EV sum, right? Because you're adding up whether you win or lose or how much money you have at the end. So that's going to be your summing those values. Give or take how much, remember that's your wiggle room. So with this model where we're replicating rolling a die 400 times, then the give or take will be the standard error. of the sum of the draws, which is similar to the SD of the sum of the draws. But anyway, so it will be the SE sum. And those formulas you should have in your notes. I really hope that you still have them. If not, let me know. But so that's what you would do for part A. And then part B is we're then going to use these values for EV and SE sum to find the chance that we lose more than 135. So that's where we talked about on an, oh my goodness, that's horrible. On a normal curve, the mean will be in the middle. So this would be the EV sum, whatever that is from part A. And then give or take a standard error, right? So each one of these on the normal curve is a standard error, right? And this is minus a standard error below. Anyway, so the chance that they lose more than 135. So when you do the menu 652 or the norm CDF, then lose more than 135. Remember, if you lose a lot of money, that's a large negative number. So the lower bound will be that negative infinity, or that whatever the value is in there, negative 9e something. Anyway, and then your upper bound will be negative 135 because you're still losing that amount. And then your no, sorry, wrong. My brain's not working. Okay, and then your mean will be the expected value, which is whatever you got there. And then your SD will be the SE sum, which is whatever you got there. And then that will be the chance of you or a person losing more than $135 playing that game. But so that should help you answer 3A and B. And then on 3C and D, first of all, the box model for C is how many times do we expect them to win? So like I said, this model, if we're only counting when we win, then just those two sides of the die will be the ones we count. So the 1 and 6 is where we win. So I'm just going to mark those as 1 because I'm just going to count up whether I win or lose. So lose, I'm just going to say is 0. Win, I'll say is 1. So 2 of the sides will win. The other 4 sides we lose, right? So the probability of winning just one roll of the die is 2 out of 6 or 1 out of 3. So that's what the average of the box model will be, is 1/3, right? So that'd be 1/3 or 0.33, whatever you want to put. Anyways, and that will help you find the EV sum. And then remember, for the SE sum, you do need to put these numbers in a list and find the SD of the box. And then that will help you find the SE sum. So let's see. Oh, and then on number 4 too. Oh, wait, before I move on, sorry. So number 3, once you find the EV sum, SE sum on 3, then you can answer this, find the chance using the menu 652 or the norm CDF. And more than 140. So remember, this is going to be part of your bounds. So it'll either be part of your lower bound, upper bound. So just make sure you read that question carefully. And then on 4, so if you think when you toss a coin, you have 2 ways that it could land, right? So this problem right here is only looking at when the program returns with a heads. So that means in our box model, we only want to count the heads of a coin, not the tails. So we're just going to have 1 1 and 1 0, right? Because that's just counting the heads and this is the tails. And then this program here did 1,000,000 tosses. So then what you want to figure out, well, and this I hope is common sense, because if you toss a coin 1,000,000 times, how many heads do you expect to get? So hopefully you can answer that without even looking at any formulas, just thinking, oh yeah, half of 1,000,000, so the EV sum should be 500,000, right? And then the SE sum, you will have to find. I will tell you that when you have a box model with the same amount of ones and zeros, then the SD is always 1/2 or 0.5. So the SD of the box, I'll tell you this, SD of the box is 1/2 or 0.5. Oops, that's not very pretty. And then that should help you with the SE sum, because it's SD of the box times something, should be the square root of the draws, but anyway, and that will tell you the SE sum. And then looking at that, so if say your SE sum is 1,000, okay? So if this is 1,000, if you think about on a normal curve, oh my goodness, I'm gonna redo that. Think with all the normal curves I draw, oh geez, that's not cute. Okay, we're just gonna go with it. Okay, so the expected value is right here in the middle, right? So this is our 500,000 heads that we expect in this program, that's going to toss it 1,000,000 times. And then if you think on a normal curve, you have 68% of the data is within your one SD, about 68, then about 95 is within two SDs, and about 99.7 is within three. So anything outside of two SDs or standard errors, since we're looking at SEs this time, so anything outside two SEs would be really unusual. Outside three is very rare, because that's that 0.3% of the data. But anyway, anything outside two is still in that outside the 95% of the time. So if your SE sums 1,000, and I don't know, is it? No, it's not. Anyway, I'm not gonna tell you what it is, but say it is 1,000, then this would be, 501,000, right? This is small, but 502,000. So then is that reasonable to expect this many heads? Okay, so I just want you to use common sense here. Like, is something wrong with this program, or is it likely to happen to observe this many? Does that make sense? Okay. So I remember I told you guys that I would show you how to find the SD shortcut, because I'm going to have to help you with that on number 5, because I'm not going to have you put in all those numbers in a list. That would be a pain in the butt. And same with 6. Okay, so this is what I ask that you do from now until Wednesday. I know we're not officially supposed to start till Wednesday, but you guys are just ahead of the game. So what I'd like you to do is just set up the box model for 5, 6, 7, and 8. And if you can find the average of the box model, great, but don't worry about the standard deviation right now, because that I will help you with on my next recording that I share with you. So if you can finish 1 through 4 all the way, great, and then just set up the box model for 5 through 8. And then I will talk to you again. Well, I won't actually talk to you, maybe. Who knows? But I'm going to put a video up again on Wednesday. So until then, just let me know if you have any questions or you need help. All right. Thank you.